Hi everybody, we're going to look at weak acids and bases. You should have your notes in front of you. You should be looking at the type 1 sample problem, and I'm going to go through and explain the calculations. So when dealing with weak acids and bases, we essentially do the same thing whether we're finding the pH or the concentration. You're going to use your log button still. But before we can do that, we have to figure out how much is dissociated because not all of it breaks into ions. So step 1 is we write down the equation. Now I know HX isn't really an acid, but that just means it stands for any weak acid. So we know in the equation this is 0.5 molar. But what we don't know is the H3O plus, and we have to find that by figuring out how much of it dissociates. So you take your percentage, 1.8%, you divide it by 100 to make it a decimal, and you get 0.018. Now you take that number and you multiply it by the concentration in the question, which at this point is 0.50. When you do that, you get an answer of 0.009 molar. Now that is how much dissociates. So that's your H3O plus, and it also happens to be your X minus because they're both a 1-to-1 ratio. So the question says calculate the molar concentration of each species. So we've done that for H3O plus. We've done that for X minus, but we're not done that for HX. Sorry, can't talk. So HX concentration was 0.5 molar, but we have to subtract the 0.009 that dissociated out, so we end up with 0.491 molar. Now, hopefully that makes sense. Keep in mind, not all the questions will ask for all the species. Sometimes it will just ask for the H3O plus. So moving on to type 2, we have a 0.1 molar solution of acidic acid, which is CH3COOH, and it dissociates 1.5%. Find the H3O plus and then find the pH. So we write our equation like usual. That actually says CH3COO minus. Actually, I'm going to erase it and try again. There, that looks a little bit better. So I know that this is a 0.1 molar solution to begin with. Now we're going to take our 1.5%, divide it by 100, so we get 0.015, and I'm going to times it by the 0.1 in the question, which is our original concentration, and I get 0.0015 molar. So this ends up being our concentration of H3O plus. So H3O plus equals 0.0015, and then you take the log of it, it'll be negative, and then you make it positive and your pH is 2.82. Again, if you're still struggling with the log thing, don't move on to this lesson. We got to have a conversation of some kind to figure it out. So going on to number 2 of type 2, we have MOH, which just stands for any base. We dissociate it like always, and we treat it the same as we would the question previous. So we have 0.2 molar here. To find the OH concentration, I have to take my 1.2%, divide it by 100. I get 0.012, and I times it by the 0.2 molar from the question. And we end up getting 0.0024 molar. So that is what our OH minus is. So then it asks for the pH and the H3O plus. So you can do it one of two ways. You can find the pOH by just logging our OH concentration. You get 2.62. Then if you take that, you can get the pH, 14 minus 2.62. That equals 11.38. Now, to get the H3O plus, you have to take your 11.38, make it negative, and hit second function log, and you should get you should get 4.17 times 10 to the negative 12 molar. Now, go through and do the math, even though you have the sample problem written in front of you, to make sure you can get those numbers. Moving on to type 3, we're working a little bit backwards because they've given us the weak acid concentration, they've given us the pH. We have to find the H3O plus and then the percent dissociation. So like every question, we write down the equation. We know it's 0.2 for a concentration. The pH is 1.65. So to find my H3O plus, I'm going to go, depending on your calculator, I'm going to go second function log, make it negative 1.65, hit equals, and we should get the answer of 0.02238 molar. Now you'll notice I'm not rounding off. I'm leaving it with 5 decimal places because it will be better for our final answer. So to calculate the percent dis, you have to take the amount disassociated hopefully you guys can read that, divided by the original concentration. So in this question, we have 0.02238. We divide it by the 0.2. And then you, of course, times by 100 to put it into percent, and you should get 11.2%. So try the math. Make sure you can get what I got. So with our last sample problem, I've written out the equation. We know that it's 0.3 molar to start. We know the pH is 11.9. So find the OH concentration and the percent dissociation. So the first thing you're going to do is you're going to go 14 subtract 11.9 and you're going to get 2.1, and that's the POH because we want the OH concentration. So to find the OH concentration, we're going to go second function log negative 2.1. And when you do that, you should get 7.9433 times 10 to the negative 3. Now to find the percent dis, you take your OH disassociated. So this goes up here, first of all. So we're going to repeat with the 7.9433 times 10 to the negative 3 molar divided by the original concentration of 0.3 times 100. And when we do the math on that, we should get 2.65%. Remember, if you have any questions, be sure you text me, email me, FaceTime me, whatever works, and get your assignments into the classroom on time so I can mark them and put them into Maplewood.